The PI3K ACT signaling pathway. The PI3K ACT signaling pathway consists of many activators, inhibitors, effectors, and second messengers. Because of its many loops and branches, the pathway is very complex and far from understood. Here, only the most important circuits will be presented in a simplified way. Activation of PI3 kinase. The PI3K ACT pathway starts with the activation of phosphatidyllinositol 3 or PI3 kinase. This activation can be accomplished via 3 different pathways. 2 pathways begin with the activation of a receptor belonging to the family of receptor tyrosine kinases by an extracellular growth factor. Binding of the factor leads to the dimerization of the receptor monomers and the heterologous autophosphorylation of the monomers. Depending on the receptor, different proteins may bind to a phosphorylated domain. The insulin receptor substrate 1, or IRS1, binds to the activated IGF-1 receptor. For simplification, this receptor is depicted as a dimer. Receptor-bound IRS1 serves as a binding and activation site for the PI3 kinase. In addition, PI3 kinase may bind directly to a phosphorylated receptor tyrosine kinase. A completely different mechanism of PI3 kinase activation begins with the small membrane-bound GTPase RAS. By binding to active GTP-bound RAS, PI3 kinase is activated. Formation of the second messenger phosphatidyllinositol 3,4,5 trisphosphate PIP3 and activation of ACT. At the second level of the pathway, the second messenger phosphatidyllinositol 3,4,5 trisphosphate or PIP3 is formed. This leads to the activation of the serine threonine kinase ACT. The active PI3 kinase migrates to the inner side of the cell membrane and binds to phosphatidyllinositol 4,5 bisphosphate or PIP2, which is a regular component of the membrane and is anchored by its 2 fatty acids in the lipid layer of the membrane. PI3 kinase is able to phosphorylate PIP2 to PIP3. PIP3 can activate the kinase ACT, which is also called protein kinase B and was named after its homologous protein in the retrovirus ACT8. Downstream effects of ACT. ACT, a serine threonine kinase activated by PIP3, is a proto-oncoprotein with many substrates and effects. Here only 3 effects will be exemplified. The best-known effect is the inhibition of apoptosis, programmed cell death. ACT binds to BAX and hinders its ability to form holes in the outer mitochondrial membrane. In the absence of ACT, these holes lead to apoptosis via the caspase cascade.